I don't know if you guys actually caught the presentation today towards the fag end of the keynote address. There was actually a person that came in. I don't remember the name of the person, but it was a great presentation. It was actually showing you how it's like a mechanical dog learns how to use data to get better at walking through all the different kinds of terrain. I think that was really cool. It was different in the sense that it actually showed you what you could do with data. I think a lot of the presentations that we had today was what you can do on the left-hand side. You can move data from this place to this place and do all this cool stuff. But I don't think we got a chance to look at a lot of the cool stuff, right? So I think that in that vein, what we're trying to do is basically say, hey, can we look at architecture and what we need to do from the standpoint of the value that we get from the architecture? That is to say, what's the business value we can get from the architecture, right? So before I get to that, I just want to talk a little bit about the context of what's happened. So for a long time, architecture has been very focused on left to right. It's all the steps that we need to do with the data, but it hasn't really thought very much about what you can do from an insight platform standpoint and what you need to do to hydrate the insight platforms. With the explosion of AI and with the explosion of unstructured data, what we see is that there's actually now unstructured data in the pipelines, right? It's more than data, and then you get to ML. Now there's actually stuff that you need to do with ML in the pipelines. You need to actually deal with unstructured data in the pipelines. You need to deal with AI for data. It used to be like data for AI. Now you have AI for data as well. All that to say that in the pipelines, that is to say that in the transformations, we need to deal with unstructured data, which is different than before. In the pipelines, we need to work with ML for data, which usually typically means that we need something like PySpark to do that. And I think that's one of the reasons why there's a need to actually change from a SQL-based pipeline to a PySpark-based pipeline. I hope that makes sense to a lot of you guys. So talking a little bit about the problem, right? So in the legacy data architectures, there's been a bunch of problems. In terms of, we had data kind of locked up in proprietary formats and so on. And what we want to do is actually get to this new system where we're actually moving that stuff to an intermodal container format. So there's a supply chain kind of analogy. We're saying, can we actually get that data out of all these systems like DB2 and all these proprietary formats into an open format? With Delta Lake, of course, you have that intermodal conveyance for your data. And the distribution modalities, you ought to be able to actually do both processing as well as like consumption in any system. So from a processing standpoint, if you want just Spark or Databricks or Spark pools, or so for example, Synapse Spark pools and so on and so forth, you ought to have some kind of flexibility depending on what the use case is in terms of how you're actually processing or consuming that data. The next thing is the invisible intelligence. And what we're basically saying here is that in the legacy architectures, what we had was some really good information about the entities, but the joins also have a lot of information in them. So I think that that's very, very crucial. I'm going to tell you about how we're kind of extending the architecture to be able to actually expose that join information. So in the old world, when we said we had semantic knowledge or semantic layer, it basically just gave you the entity information, but not the join information. The DNA of the enterprise, of course, is actually in the join information, not in the entity information. How do you actually expose that stuff? And the language barrier is we're basically saying, hey, can we actually make it really easy for business guys to get at both the entities as well as join information? That is to say that can we imagine SQL where there is no primary keys, there is no foreign keys, there is no joins. They actually have a business meaning. These things actually have a business meaning. So imagine rewriting SQL with like none of those things. It's just basically all the joins are represented by brother of or sister of or subproduct of or region of blah, 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 blah. Being able to do that actually exposes a lot more features for what we want to do from an insight standpoint. Make it easy to shop just refers to the fact that we want like a data product kind of concept going on, where it's safe and easy for different people to get the information that they need. And the analysis paralysis is actually a new consumption pattern that we're going to talk about. We think that with the new architecture and with some of the new technologies from a consumption pattern standpoint, we can get past the problem with BI, which I'll talk to in just a few minutes. But whatever we're trying to do with cuts of data, the millions of cuts of data and so on and so forth, even for example, some of the demos that we've seen saying, can you find what's actually changed with this metric and so on and so forth, that is a lot less crucial than basically being able to understand the KPIs of the company and what's driving the KPIs of the company. So that's what analysis paralysis means is, can you find a way for the system to tell you what things you need to be looking at as opposed to you looking for it? So on the so this is a problem that I talked about. And then we talked about the purpose in terms of, what are we trying to do? When we say something is an insight-first architecture, what do we mean by insight-first architecture? All from the standpoint of how you consume this data to drive your business. If you look on the left-hand side, enterprise reporting, if you look at dashboard and alerts, if you look at self-service queries, and if you look at query by code, all of them are very clearly possible, have been possible for decades now. So that's never been a problem. What's actually been much more of a problem is actually on the right-hand side. The ability to do real-time monitoring has been a problem. The ability to do ML training has been a problem. The ability to do ML serving has been a problem. And autonomous analytics, I'll show you a real example of, I think this is like really a massive change in terms of what you can do with your data to drive the performance of your business. So very much like, what sort of happens as a result of all this stuff, it's not moving the data around. I'll show you a business example of how you can drive performance for your business. So I talked a little bit about the problem with legacy architectures. I talked a little bit about what the purpose of what we're thinking about. So the insight-first architecture is really driven towards driving insights and all the 8 patterns of consumption that I talked about. So how do you actually get there? What's the path to that, right? So that's basically saying, how do you hydrate the systems of insights? So if you actually look at this, what we're trying to do is very, very minimally affect what the Lakehouse architecture is. So we're saying, can we work with something that we know has worked well or can work well, but then actually just fill in the small gaps that we need to fill in, but be really, really true to the Lakehouse architecture as much as we can do it. So on the left-hand side, it's exactly what you've seen before. Can we actually handle the different kinds of data? It's like small data versus big data. It's the unstructured data versus structured data. It's the anytime data versus the now data. So all those patterns we're able to handle. Of course, streaming comes in. This particular view is actually an Azure edition of what we can do, but this could apply to AWS. This could apply to any platform, really. So in this Azure thing, there's actually a way to actually bring it through the streaming service, which is the top streaming stuff that's coming in. It's dropping in the raw landing zone, which is ADLS. And then you have the other stuff that's actually batch stuff that's coming into the ADLS stuff as well. If you look at basically the raw landing zone, it's a dumpster fire of lots of this information just dropping in there. So we don't want anyone to report off of that, and I don't think many people report off of that stuff. It's basically only run IDs that are actually are able to use that stuff. And then the rest of the stuff is you're basically saying, let me process that to usable layers. So there are 3 usable layers, and 2 of those usable layers are things that you guys recognize, which is basically within the Lakehouse. There's the bronze Lakehouse layer that you guys are all used to. And the processing to get it from the dumpster fire, which is the ADLS thing, to this one is exactly the same. The only thing that we're saying is, look, there's some level of thinking about what you want to use for processing. If you're trying to do, for example, in the Azure world or the Microsoft world, some Power Apps, and you want to kind of take advantage of some .NET integrations, it might make sense to use, for example, Synapse Spark Pools instead of Databricks. But if you want really performance stuff, obviously we know what the answer there is. We want to use Databricks for that. So for each layer that we have, that's an option that you have. If you're trying to do something that's taking advantage of some specific things, you have an option of doing that. But if you're looking for highly performant data processing kinds of things, Databricks is obviously the choice. That's what we're really talking about. So in the first layer, what you get is your batch data and your real-time data in the same format. So you're using the same tools to get to it. So you have ACID compliance and it's stable. So it's basically a stable transactional database you can report off of. And then very similarly to that, you get, again, an option of what processing platform you use. You get it to the Lakehouse Silver layer, which is, again, as in the traditional form, what we're saying is you get like schema enforcement, and then you also get data expectations, right? And then this is where there's actually a modification of the Lakehouse architecture. What we're doing is, again, use the same processing tools. There's no change at all in the processing tools. But what we're giving you is in the Timber platform, and we have the founders, the guys from Timber over here. So they've come up with this very clever way of making graph technology available in PySpark and SQL and so on. The problem historically has been that to do graph stuff, you need to do PySpark or Cypher, you need special infrastructure and so on and so forth. It's kind of difficult to scale. I don't know about your guys' experience, but in my experience, it's been somewhat difficult to scale those things. So what we're basically saying is, can we actually use the same skills we used before? Same type of people, same kinds of technologies. It's a SQL and Spark kind of technology, especially if you're doing ML stuff. It's like the Spark kind of technologies, but yet be able to do all the things that you'd be able to do with a graph. Now, that graph layer is actually a virtual layer as opposed to a persisted layer. And we're saying, look, that sort of looks like a relational platform. It uses relational tools, but it also has caching, because sometimes what we have is some performance issues when it comes to virtualization. We're saying, can we actually use caches very intelligently and as like a 3-stage cache, so you don't run into performance issues when you're actually trying to use this stuff, but do all the tools, whether it's processing tools, consumption tools, that looks like basically relational technology and relational stuff. And because we're actually relying on proven technology, we know that it actually scales, and there's lots of examples of this as well. Now, that is the business layer. So we're actually replacing what we would call the goal layer as the business layer. This is actually tremendously important, because what it does is now it gives you both the entity information as well as the join information. And you can expose that as there's actually a table format that's called denormalized Timber. Now you have maybe, I don't know, 30%, 40% more features, but then you also have like graph ML kinds of things, for example, community detection and so on and so forth. So you can actually just punch in attributes like community IDs and so on and so forth that you can leverage further. It's really, really, so when you actually go into an enterprise, you're trying to do some insight-driven stuff, what we're finding is that in most cases, people are using maybe 60% of the data. That's really, really crucial to understand, right? The other thing to kind of understand is the reason why digital transformation is stalled at most enterprises is because they have not been able to look at this join information. So people have access to the semantic layer. The semantic layer is mostly the entity information with some join information that's sort of showing up as an entity. So using primary keys and foreign keys and joins and set operations and so on and so forth is just basically artifices that we're trying to do to surface some of the join information that's actually important to us as things that we can use in analytics. We don't want to be limited by that. We want to actually look at all the information, all the join information. There should be no joins in the semantic layer, right? All that should be available for analytics. And essentially, we're using that virtual layer to hydrate all the different consumption patterns. So, for example, you have batch BI, where you might want to use some kind of cloud warehouse. Now, again, I don't know a lot of our clients actually have all the technologies and trying to figure this out in terms of how these things fit together. So they have Databricks and Warehouse and Azure Synapse and everything. And I think we're kind of trying to struggle with getting them to see when to use what. I think that processing is always better in the Lakehouse, but once you organize it, you might actually put it into something like Snowflake, which is really good at mass consumption BI stuff. So once you actually organize it outside in the Lakehouse, you punch the final organized information into Snowflake or whatever, or Power BI and so on and so forth, and make it available for mass consumption by thousands of people. That makes a lot of sense, because I think it's a really good tool. But other than that batch BI, the ad hoc BI stuff, much better with Databricks, in my opinion. Real-time stuff, much better with Databricks, in my opinion. AI, ML stuff, of course, there's much better stuff, much better things that we can do with Sparkle, with PySpark. Now, the only thing with ML stuff is that anything that gets used by a model needs to be in a feature store. So if it's something that sort of it needs to be live available, that's in an online feature store like in Redis in the Azure world. If it's an offline feature store, offline features, we push it back. And what you're seeing there in the offline feature store is actually the feature store that we don't need live in applications. We're pushing it back to the Lakehouse. That is not the goal layer, right? And maybe that was a terrible choice of colors. That is really not the goal layer. It's basically the offline feature store. The gold here represents the extensions that we need to drive insights from the Lakehouse architecture. So I'm doing well on time. One of the things that I really want to talk about is this journey from data to dollars, right? A lot of you are actually involved in projects and you want to ask for more money, more funding, and so on and so forth. And you get this question of what the ROI of all these projects is. And we think there's actually a very quick way to build out something that's significant for all functions within your enterprise. So, I work a lot with financial services companies, and I might be working with the risk group, I might be working with a marketing group, I might be working with a customer group. And there's a very, very easy way to actually set something up where the system by which you actually produce these results, all you need is basically the KPI list for all of them. Once I have the KPI list for risk and marketing and customer and all that kind of stuff, there's a way in which we can actually use some technologies. So one is called Sisu Data, another one is called IBLE. Most of those technologies basically go back to the component metrics at the transaction level. They pick up the anomalies at the transaction level, and they basically look at the inliers of the anomalies. So basically they're looking at what's actually common between them. And they're able to come back, given like a list of KPIs. So for example, loss ratio and combined ratio in the insurance world, a couple of metrics that actually show up. I'm just showing you one example. It basically looks at all those different metrics. It says, okay, what's the period that you want to look at? Or you can actually use generative AI to do that. And by the way, this is called generative BI in this context. You can basically say, can you kind of help me understand what the KPIs are that are off and explain to me what things are off? It'll automatically go and look at your KPIs. It'll actually pick out the KPIs that are off from last quarter to this quarter if you tell it to do that. And there might be 17 KPIs and then 2 of them are off. It'll say, okay, I found 2 things that are actually statistically significantly off from what we've seen historically. And let me tell you exactly what's happened. So in this particular case, I'm showing you a real example of what's happened for loss ratio from last quarter to this quarter. It actually does a multivariate analysis. It says, okay, your loss ratio went up from 76% to 78%. I don't know how many of you are coming from the insurance space or have some exposure to this stuff. That's a huge deal, right? And you're saying, okay, what's actually driving that stuff? And you actually start looking at the component things that are driving the loss ratio. There's some things that are actually even driving it down. And by the way, down is good and up is bad when it comes to loss ratio. It's how much of your money you've actually spent in losses. You're starting to see the biggest effect. So there's like this cohort of young females with a credit score of between 600 and 650 are the people that are actually bringing down the loss ratio. That's good. And then you have these other ones that are actually bringing that up. And if you actually look at what this is telling you, the young unmarried males are the guys that are actually driving this stuff up the most. And I think that's really what they want to understand, right? What you'll end up seeing is you'll see in this system of tracking metrics, it's kind of like you're going from, 50 seconds. So you're going from data observability and system observability to business observability. So you can imagine a world where you're actually tracking KPIs across the entire value engineering chain. It'll automatically say from quarter to quarter or month to month or day to day or minute to minute, because of course we can do real-time stuff. It tells you what things are off. For the ones, you can say, okay, for the ones that are statistically significant, what's actually driving them? I think that's a magnificent way for you to build one solution that applies in the same way to all the different functions there's really no change you need to do to go from risk and so on and so forth. It's the same technique, same everything, but it looks like you're actually making an impact on everybody at the same time. So you're actually affecting all those functions. You're changing, you're actually sort of shortening the journey from data to dollars. And I think it's going to be like a massive sort of capability. And if you show some of these quick wins, you'll get lots more money to do like larger projects when it comes to these kinds of things. So that was my prepared comments. Thanks for your time.